Sangam Tutorials, Gubbi online classes for Ncert 9th standard and Cbse 9th standard. So in the previous session of polynomials, we had discussed regarding the zeros of a polynomial. So how to find the zeros of a given polynomial, and we also checked whether certain real numbers are the zeros of the given polynomials or not. So these were the very simple problems, and I feel very happy to see you sending the homework to me through the WhatsApp. So I appreciate your interest. So at the same time, you should maintain that for a long time so that you get a good grip on the subject, right? So in today's session, we are going with a very interesting concept, that is the previous knowledge required to learn factor theorem. So this is the most important one. So most of the students, they concentrate only on factor theorem, take the result and they start applying wherever it is required. But actually you should be knowing why we need a factor theorem, what is that factor theorem, so what is the theoretical background of the factor theorem. So before learning factor theorem, that is, I am going to teach you in the next session. Here in today's session, we are going with the basics or the previous knowledge required for learning factor theorem. This is very, very important. This is the knowledge class, right? So in the previous classes, you have done a lot of divisions. So you were given two numbers, divide this number by this number. You used to divide it, you used to get two new numbers. Only two numbers were given to you, so that, for example, if two numbers like A and B were given to you, and if you are asked to divide A by B, then you used to get two new numbers. That is, among them, one is the quotient, another is the remainder. I hope you remember now. So the same criteria we are going to take up now, and we are going to connect a new concept to the things what you have already learned, right? Okay. So for example, let us take the number 12. Let us take, very simple, let us take number 12. You know that it's a real number. Okay. Let us divide that 12 by 3. Okay. So 12, I am going to divide this by 3. So 3 4 times is 12 and the remainder is 0. Nice. You know this. So I gave you just two numbers, 12 and 3. So what you did is, you did the division process. 3 4 times is 12 and the remainder is 0. So here you have got two new numbers, that is 0 and 4. So here it is called as the quotient. This is called as the quotient, and this is called as the remainder. This is called as remainder, and this is the divisor. This is the dividend. This is the dividend, and this 3 is called the divisor. This is called divisor. So this is divisor, dividend, quotient and remainder. So four things we have, right? So now, when you divide a number by another number, and if you get 0 as the remainder, we know that then two things happen. When you divide a number by another number, and after the division process you get 0 as the remainder, then we come to two very important conclusions. So among those two conclusions, one is 3 is a factor of 12. That is the first conclusion, because we have got the remainder 0. So therefore 3 is a factor of 12, and 12 is a multiple of 3. That is, in 3, okay, very simple, in 3 1s tables we get 12. That is 3 multiplied 1 time, 3 multiplied 2 times, 3 multiplied 3 times, 3 multiplied 4 times. What the tables, maybe you have by hearted. So in that 12 comes. So therefore 12 is called the multiple of 3, and 3 is called the factor of 12. So this is one thing. So here we set up, we have four terms here. One is the divisor, dividend, quotient and remainder. So we set up a relation between these four things, that is dividend, divisor, quotient and remainder. So that comes like this. So dividend is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. So divisor is that is 3 into quotient is 4 plus remainder is 0. So 3 into dividend is 12. I will substitute here. So 12 is equal to 3 into 4 is 12 plus 0. So 12 is equal to RHS. So this is the relation between the dividend, divisor, quotient and remainder in any division. Right? Okay. I will take up another example. Let us divide 25 by 3. Let us divide 25 by 3. Now, so this is the division process. 25 I am going to take here. 25 is there. 3 8s are 24. Okay. 1 is the remainder. So did we get 0 as the remainder here? No. So we have got a non-zero remainder. So here the remainder is 1. So in the process of division of a number by another number, if the remainder is not 0, then we come to two conclusions. The first conclusion is 3 is not a factor of 25 and 25 is not a multiple of 3. So that's the conclusion. So when we check this process, that is dividend is equal to divisor into quotient plus remainder. So 25 is equal to divisor into quotient, that is 3 into 8, 3 into 8 plus 1. So 25 is equal to 8 3s are, that is 24 plus 1. So 25 is equal to RHS. So here this thing what we have here, the relation holds good for all types of divisions here, all types of divisions. No doubt in that. So if you get remainder 0 also, that the relationship satisfies. If you get a number which is a non-zero, then also the relationship satisfies, you can see here. So, but one thing is, what the conclusions we came here and what the conclusions we came here are totally different. So here, in this, as the remainder is 0, we say that 3 is a factor of 12 and 12 is a multiple of 3. But in this case, as we have got 1 as the remainder, 3 is not a factor of 25 and 25 is not a multiple of 3. That's the conclusion we get. So these things you have done in your previous classes. Just I try to remember and recall and or recapitulate the things what you have learned in your previous classes. Now, as we are discussing regarding polynomials, so let us see the same rule is applicable to polynomials or not. Is the same rule applicable for polynomials or not? We are going to check it out. Okay. Let us take two polynomials. Let us take two polynomials here. So one is let p of x is equal to 2x square plus 3x plus 1. I am taking one of the polynomial, and we will take another polynomial as g of x is equal to x plus 2. This is another polynomial, right? So if you observe here, the degree of polynomial p of x is greater than the degree of polynomial g of x. That's very important. So in case of polynomials, when we are applying this concept, you have to very keenly observe the degree of the polynomials which we are taking. So here the degree of p of x is 2 and the degree of g of x is 1. That is the highest degree of the variable x is 1. So therefore it is a quadratic polynomial and this is a linear polynomial. So now let us divide p of x by g of x. So we will go with a new process where you have not learned it earlier. It's very important, it's very nice, you will enjoy it. So this is called the long division process. This division is called as long division. The process of dividing a polynomial by another polynomial is done by the method or process called long division process. And here we follow certain steps in that. So a series of steps where it is followed, where we follow a series of steps to reach the desired goal. The series of steps what we follow to reach the desired result or desired goal is called as an algorithm. It's called as an algorithm in mathematics. Okay. Let us take this polynomial, that is 2x square plus 3x plus 1 is the polynomial, and this is x plus 2, which is the divisor. Okay. So this is the divisor and this is the dividend. Now let us divide this p of x by this g of x. So please look at the steps very carefully, look at the algorithm very carefully so that we can reach to the desired result. Okay. Now take up the first term and look at this first term here. Here we have 2x square and here we have x. So what should be multiplied to this x to get 2x square? What should be multiplied to this x to get 2x square? So I have to multiply that by 2x. X into 2x is 2x square. Sir, I am not able to guess it. Sir, I am not able to guess it, sir. I am getting confused. Okay, no problem. Take this term, 2x square. Take this term, yes, x and square cancels. So you are left over with 2x multiplied by this. That is x into 2x is 2x square. Write 2x here. So that can also be done. But this is the manual method of doing this. But if you imagine the term which is to be multiplied, okay, that's good. Okay. So x into 2x is 2x square. And now this is the second term. Multiply this 2x by the second term also with sign. So plus 2 into plus 2x plus 2 into plus 2x is plus 4x. Right? Now x into 2x is 2x square plus 2 into 2x is 4x. So here we have to write the term what we have got with the like term in the polynomial just below that. So now in this step we have to subtract this from this. So therefore the sign of the terms changes. So plus 2x square plus minus 2x square cancels. Plus 3x minus 4x is minus 1x and we have to take this down. That is minus 1x plus 1. Okay. Now x into what gives you minus 1x? Very simple. X into what gives you minus 1x? So x into minus 1 gives you minus 1x. Plus 2 into minus 1 is minus 2. Okay. Subtract this from this. So therefore sign changes. So this is plus here. So minus 1x plus 1x changes. So that is get cancelled. Plus 1 plus 2 is 3. We have got as the remainder. So we are going to stop it. We are going to stop this division. So why we have to stop the division here? Because here it's a constant. 3 is a constant. So what is the degree of a constant polynomial? The degree of a constant polynomial is 0. The degree of the constant polynomial is 0, but the degree of the divisor here is 1. So as the degree of the remainder has become less than the degree of the divisor, therefore the division stops. We stop the division. I hope you got the point. As the degree of the, what is this 3? 3 is a constant. What is the degree of a constant polynomial? The degree of a constant polynomial is 0. But the degree of this linear polynomial here, that is the divisor, is 1. As the degree of the remainder is less than the degree of this divisor, therefore we stop the division process. Right? So now here we call this 2x minus 1 as the quotient. We call it as the quotient, and we call this 3 as a remainder. We call this 3 as a remainder. So now, does the same rule apply what we had applied for the numbers there? Yes, the same rule applies here also. So here we say that as the remainder is not equal to 0, as the remainder is not equal to 0, therefore x plus 2 is not a factor of 2x square plus 3x plus 1, and 2x square plus 3x plus 1 is not a multiple of x plus 2. So this is holds good. It holds good. Yes, 100% it holds good. So now let us check out the result, that is p of x is equal to g of x into, let us call this quotient as it begins with q. Let us call it as q of x plus, as this is the remainder starts with r, let us call it as r of x. So p of x is 2x square plus 3x plus 1 is equal to g of x is x plus 2 and 2x minus 1 plus r of x is 3. So 2x square plus 3x plus 1 is equal to x into 2x is 2x square, x into minus 1 is minus x, plus 2 into plus 2x is plus 4x, plus 2 into minus 1 is minus 2 plus 3. Right? So let us simplify this. 2x square plus 3x plus 1 is equal to, let us check this out, 2x square is there, minus x plus 4x is 2x square, minus x plus 4x is plus 3x, plus minus 2 plus 3 is plus 1. So here you can see LHS is equal to RHS, 100% it has become equal. So this result what we are applying for this division of polynomials, here it is called as the division algorithm for polynomials. This is called the division algorithm for polynomials, which is very, very important. This is the very important previous knowledge required for solving problems, right? So now, okay, it's a very nice thing, you learned long division method. So here, let us take another example and let us see the next concept, how it is going to get applied. So let us take another polynomial. Let p of x is equal to x square plus 2x plus 1 and g of x is equal to x plus 1. So you can observe the degree of p of x is more than the degree of g of x. So let us divide this. Let us take the process. So it is x square plus 2x plus 1 and the divisor is x plus 1. So now x into what you see x square, it is x. X into x is x square, plus 1 into x is plus 1x. So let us subtract this from this. So sign changes for every term. Plus x square minus x square cancels. Plus 2x minus 1x is x, plus this comes down, so it is x plus 1. So now x into what gives you plus x. X into plus 1 gives plus x. Yes, x into plus 1 is plus x. Plus 1 into plus 1 is plus 1. Okay, we have to subtract this from this. So sign changes. Minus x plus x cancels. Plus 1 minus 1 cancels. The remainder is 0. Right. So does here we have got the remainder as 0. Now 0 is a constant. 0 is a constant. So what is the degree of a constant polynomial? The degree of a constant polynomial is 0. So therefore, as the degree of the remainder is less than the degree of the divisor, that is 1, we say that the division process stops. Or very simple, in other words, if the remainder is 0, when you divide a polynomial by another polynomial and the remainder is 0, then we say that the division process stops. So here, when we get the remainder other than 0 as a constant, as the degree of the constant polynomial is 0 and it is less than the degree of the divisor, so therefore the division process stops. So at two instances, the division process is going to stop. One thing is, when the degree of the remainder is less than the degree of the divisor, the division process stops. When the remainder is 0, then the division process stops. Okay. So if we apply division algorithm for polynomials here for this polynomial, does it apply? Yes, 100% it applies. Nice, very nice. So here in this case, this is called as the quotient. This is called as the quotient and this is called as the divisor and this is the remainder. So and you know that this is the dividend. Right. So now, okay, you are well versed in this now. When I give you more number of polynomials like this and this, I hope you will be able to carry out the division process. So more number of problems are going to come in the next sessions. I will teach you how to go with long division. Right. Now, see, in order to get this remainder 3, please listen to me very carefully. In order to get the remainder 3, I had to divide this polynomial p of x by g of x and I had to go a large number of steps involved in that. Maybe 2 steps I have got. If I got 2x to the power 5 something plus 3x to the power 4 plus 9x square plus 20x plus 1 and divide by x plus 2, then I will get a lot of steps. So at last I am going to get the remainder. So here I am going to discuss when we divide a polynomial, any polynomial p of x by another polynomial g of x, where the degree of the polynomial, that is the degree of the g of x, is less than the degree of p of x. So once again I will repeat. I will give you 2 polynomials. One I am going to call it as p of x, another one is g of x, and I will ask you to divide p of x by g of x. So here the degree of p of x will be equal to or greater than the degree of g of x. That is the condition, right? Right. If I do this process, if I do the long division process by taking those 2 polynomials, at last I get the remainder. Don't we have any simple method to directly find out the remainder without doing actual division by using these 2 polynomials? So very simple. In order to, when I divide this polynomial by this polynomial, I get the remainder 3, but number of steps are more. Do we have any simple method to find out the remainder when a polynomial is divided by another polynomial without doing long division, without doing any division process? Is that possible to get the remainder directly? Yes, we have a method. We have a very beautiful method. What is that? Very simple. When a polynomial is divided by a linear polynomial, compulsory, I cannot take a quadratic polynomial here. Inside I can take cubic, inside I can take biquadratic, inside I can take, as the dividend I can take x to the power 5, x to the power 6, x to the... For the dividend there are no restrictions, but for the divisor we have restrictions. That is, the divisor should be compulsory a linear polynomial. So when a polynomial p of x is divided by a linear polynomial only, then the method what I am going to teach you now applies, or else not, or else it is not going to get applied. I hope you got it. The method what I am going to teach you to find the remainder directly without doing long division applies only for those 2 polynomials where p of x can have any degree, but g of x should be compulsory a linear polynomial. So you can observe here, this is a linear polynomial I have taken. Here also I have taken a linear polynomial. So this trick or method applies only when the divisor is a linear polynomial. Yes, let us get into the method. Now let us take the first example. Let us take it. P of x is equal to 2x square plus 3x plus 1 was the polynomial, and g of x was x plus 2. So when I divide this polynomial p of x by this polynomial g of x, I already know that the remainder is 3 by doing long division process. Now I am going to teach you the method of finding the remainder directly when this polynomial is divided by this polynomial. Condition is this polynomial should be, yes, it should be a linear polynomial only. Let us go get in the method. I hope you remember the concept of zeros of a polynomial. Zeros of a polynomial. Okay. What is the zero of the polynomial g of x? What is the zero of the polynomial g of x? You have done a lot of problems on finding out zero of a polynomial. So what is the zero of the polynomial g of x? So g of x is equal to x plus 2 if you want to find the 0 of this polynomial, let g of x is equal to 0 you are going to put up. I hope you remember. Therefore, x plus 2 is equal to 0. Therefore, x is equal to minus 2. X is equal to minus 2. Now, I will take this minus 2, which is the 0 of this polynomial g of x, and substitute that value in p of x. I will do it. So, p of x is equal to, p of minus 2, I will directly take it. I am going to substitute this. So 2x square, so 2 into minus 2 whole square plus 3 into minus 2, where x is there I am going to substitute minus 2 plus 1. So p of minus 2 is equal to, minus 2 whole square is 4, 4 2s it is 8, plus into minus it is minus, 3 2s are 6 and plus 1. So p of minus 2 is equal to 8 plus 1 is 9 minus 6. So p of minus 2 is equal to 3. P of minus 2 I have got 3. So here this 3 is the remainder. This 3 is the remainder when this g of x divides p of x. That is, when p of x is divided by g of x, then the remainder is 3. This 3 is nothing but this 3. There we did the complete division process, long division process to find the remainder. Here we use the concept of 0 of a polynomial to find the 0 of a polynomial when it is divided by a linear polynomial. So it was the polynomial, it is the linear polynomial. We will find out the 0 of this. We will substitute that value what we have got into the polynomial. The value of that polynomial what we get here is the remainder when this divides this. Let us check this one. Let us check it out. Sir, maybe what we have done, maybe a coincidence, sir. Give us another example. Okay, no problem. Take another polynomial. P of x is equal to x square plus 2x plus 1, and g of x is x plus 1. This is a separate problem. Let us do this now. P of x is x square plus 2x plus 1 and g of x is x plus 1, right? Now, find out the 0 of g of x. So, let g of x is equal to 0. Therefore, x plus 1 is equal to 0, this one. So, x is equal to minus 1. So, put this value in p of x. So, p of minus 1 is equal to minus 1 whole square plus 2 into minus 1 plus 1. So p of minus 1 is equal to minus 1 whole square is 1 plus into minus minus 2 ones are 2 plus 1. So p of minus 1 is equal to plus 1 is 2 minus 2. So p of minus 1 is equal to 2 minus 2 is 0. So this 0 is the remainder when this polynomial g of x divides this polynomial p of x. This 0 is nothing but this 0. I hope you understood the concept. So, when we divide a polynomial by another polynomial, we get the remainder, and that remainder is got by doing usually long division method. But when a linear polynomial divides another polynomial p of x, then the 0 of the linear polynomial, which will be the value of the p of x, will be the remainder when this linear polynomial divides the p of x. Right? I hope you got it. I hope you got the things. So here condition is, if you want to find out the remainder like this, very simple, equate this to 0 or find out the 0 of this polynomial, you will get a value. Substitute that value in the polynomial and that will be the remainder when this divides this. Right? I hope you got it. See, this is what I call the previous knowledge required for learning factor theorem. So, in tomorrow's session, I will be presenting the factor theorem where you are going to easily understand it because you know the basics. you have the knowledge, right? So this is called as, once again, this is called as Euclid's algorithm for polynomials, or division algorithm for polynomials, which is applicable for all type of polynomials, right? I hope you enjoyed the session. Stay home, stay safe, and keep learning. Thank you.